Hello. Good morning, Devoxx. Welcome to the last day, Friday. So this is me, I'm Simon, and this talk is going to explore the intersection between software architecture and code. And really there are two things that inspired me to put this talk together. First of all, lots of people have architecture diagrams, but they never quite match the code. People generally think this is the case as well. Yeah, I see a few people nodding. Good. And how do we create those architecture diagrams in the first place? Well, I can teach people how to draw architecture diagrams on paper and whiteboards, but then the obvious follow-up question is this. What tool do we use? And please don't recommend Visio again. So that's really the inspiration behind this talk. So I live in Jersey in the Channel Islands, which is a tiny island off the coast of France. Even on this gigantic, monstrous cinema screen, can you see it? Can I see it? No, it's like 3 pixels or something. Now, if this was a big iPad Pro type thing with the huge screen, we could pinch to zoom in, gets a bit closer, still quite small, and we could pinch to zoom in once more. And there you go, there's Jersey. Now, why do I live there? Basically, it's a nice place. I lived there as a kid, moved to London, worked in London for about 12 years, mostly building Java systems for banks and consulting companies. And I moved back to Jersey in 2008. And over the past few years, I've really been jetting around the world and helping teams understand what software architecture is all about from the perspective of technical leadership, agility, and that kind of thing. And really my whole pitch here is that I think architecture needs to be much more accessible to us as developers. Sure, there are lots and lots of books out there, but when I was moving into my first architecture role, I didn't really understand how the stuff in those books related to what I should do day to day as an architect. So how do I solve this problem? I just write some books. I write some different books. So the one on the left is Software Architecture for Developers, and the one on the right, you guys can go and download for free. And some of the stuff in the book on the right we'll talk about today. In addition to doing all this kind of hand-wavy stuff, I still do write code. You'll be pleased to know. And this is important because I think architecture and code are just two sides of the same thing. They shouldn't be separated. And that's what I'm really interested in here. It's the intersection between architecture and code. And the thing I'm specifically interested in, of course, is how do we communicate architecture? How do we visualize architecture? How do we share information about how our systems work to other interested parties? So let's set the scene. Imagine you inherit a Java code base. Let's say it's a couple of million lines of Java code. And let's say that this is maybe 50,000, 100,000, 200,000 Java classes. And somebody asks you to draw a picture to describe that code base. Would your picture include 50,000 boxes, 100,000 boxes, one for every class? No. Even on this big screen, if we were to draw it, all of the classes will look teeny-weeny, and there'd be too much complexity there. So when we're drawing architecture diagrams, we're using abstraction. And abstraction is a way to allow us to reduce the cognitive load, reduce the amount of detail that we're showing. So rather than drawing 50,000 Java classes, we clump these things together, don't we? Into bigger things, bigger chunks. And we have some words to describe these things. Components or modules or services or subsystems or layers, and so on and so forth. And the whole purpose of abstractions is that these things allow us to reason about big, complex software systems. Now, there are lots of ways we can do this, of course. There are lots of ways we can think about and describe software systems. And this quote here is from Philip Critchton's 4+1 model. And he basically says, to describe a software architecture, we use a model composed of multiple views or perspectives. So we're looking at a system from different angles, essentially. And this picture is Philip Critchton's 4+1 model. It's a logical view of how our system works, so logical components, for example. There's a development view, which is more about aligning that view with the code. There's a process view that talks about concurrency and things, and there's a physical view that talks about deployment. And all of these things are brought together by some use cases in the middle. This is one approach. There are lots and lots of other view catalogs. Every architecture book will have their own way of doing this. And that's cool, but over the years, all of the names of these views have kind of lost their meaning. So I've been in meetings with architects, and they've argued that there's a difference between a conceptual view of the system and a logical view of the system. And I'm like, what? As a native English speaker, that doesn't make sense. Development view, design view, implementation view, sometimes these are the same thing, sometimes they're different. So all of this stuff is just complicated now. The thing you will notice about all of these different ways to describe architecture is that you normally have a logical view of the system, which is modules or components or services, and then you'll have a separate development view, which is more aligned with the code. And these things are always separate. If you go and look up all the different view catalogs, there's normally a logical view and a separate view that tells you something about the code, how it's laid out, how it's structured on disk, for example. And this makes my head hurt a lot. Whenever I've been asked to draw architecture diagrams in the past, you have to get your head around all of these different viewpoints and views and perspectives in order to figure out what it is you want to draw. Now, being that we're all geeks, we could just cheat. So how do we cheat? Well, if somebody asks me to go draw a software architecture diagram, why don't I just go consult Google? Or Stack Overflow, but let's go Google first. And if you've ever done this, if you've ever typed in a query software architecture diagram and asked Google, you basically get stuff like this. It's just page after page after page of pretty color block diagrams, the type of things we see on PowerPoints and in Visio and in Word and so on and so forth. And they all end up looking eerily like this. So if we take this one I've highlighted, we always talk about layering in architecture being a good thing. So we have a diagram showing layers. But you'll notice some of the layers are different heights. Is that important? Is it relevant? Is it showing something about size and complexity? Or did somebody know, or not know, that in Visio, you can multi-select all the layers and make them the same size? Right, taking advantage of the tooling, who knows? Sometimes stuff doesn't fit neatly into those horizontal layers. We have the vertical layers that stop the diagram falling over. We've got acronyms on here. We've got no lines joining things. At least we have nice gradient shading. Looks good on a PowerPoint presentation. And of course, the same patterns repeated all over the place. And these are exactly the type of diagrams that I see when I go visit organizations. If we kind of step back a few steps, what is it we are trying to do with these diagrams? Well, if I'm drawing diagrams as part of an upfront design exercise, then really it's this question I'm trying to answer. So here's a set of diagrams. Do the diagrams reflect what I think I want to build? And of course, if we're retrospectively drawing diagrams from an existing code base, then the question is this what we actually have? I think we struggle with this a lot. I also don't think it helps that we don't have a consistent way to do this across the entirety of the industry. We lack a common vocabulary with which we can think about, talk about, draw, and describe software architectures. Think about the word component. How many times have you heard the word component used to mean different things? For some people, a component is an application in a bigger system, and for other people, a component is something that runs inside that application. So we use the same word for differing levels of abstraction, for example. Now, we could say, well, Simon, why don't we just use UML? UML, the Unified Modeling Language, sorts a lot of this stuff out. Right, I'm going to try an experiment. Quick show of hands. Who here uses UML regularly and frequently? It's not that many. Might be 10%-ish. So what's everybody else doing? Drawing boxes and lines. I've asked this question all around the world, and yeah, most people don't seem to be using UML anymore. There are a couple of exceptions. I was in Germany a couple of weeks ago. They use UML. I don't know why. I've still not discovered why. But mostly, UML seems to be falling out of favor. If you look at what UML gives you, it's trying to give you a standard set of things, abstractions, and a standard set of boxes and lines to represent those abstractions. And it's always the notational side we struggle with. One of the big objections I hear about UML is it's too complex. because you have to have all those discussions about open diamond versus shaded diamond, and then you have to go to Wikipedia and look up aggregation versus composition, and you just want to write some code. So again, let's backtrack. I think having a common set of abstractions, a common set of things, is actually way more useful than a common standard notation. That's an odd thing to say. But it kind of makes sense. And it makes sense in a number of other different fields. And let me give you a really, really good example. Maps. Let's go get 2 maps of Antwerp and lay them out on the front here. The 2 maps of Antwerp will probably show you the same things, won't they? The various areas and districts and the sites and the points of interest and the bus routes and the tram lines and the railway stations. But the 2 maps might use differing notations to describe the same things. How do we decipher the maps? Well, there's a key in the corner. So the maps are a really great example of, a common understood set of abstractions with a self-describing notation. So maybe we should try that first. Maybe we should try to get the abstractions clear in our mind. And I really do like maps. And the reason I did my silly, can you see Jersey? No, it's too small, zoom, 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 is because I like to think of software diagrams as being maps. They're maps to navigate a large and complex software system. If you open up your smartphone and go to Google Maps especially and do a search for Jersey, it will zoom you straight in. And it shows you all the detail in Jersey and where the places are and what the names are and things like this. If you've never heard of Jersey before, it's completely useless. So the first thing you do is you zoom out to get to the map of Europe, to get some context. The software diagram is the same sort of thing. Sometimes as developers, we want that zoomed-in view of the world. But actually, depending on who we're talking to, we might want to zoom out a few notches. So how do I do this? Well, for me, a software system is made up of a number of containers. A container is simply something that executes code or hosts data. In real terms, it's something like a mobile app, a web app, a database, a file system, a batch process, a standalone Java process, that sort of thing. If we zoom into the containers, for me, they contain components. So I'm going to use the word component to mean something that runs inside a process, essentially. Now, this is a massively overloaded term, of course. So for me, a component is nothing more than a bunch of related stuff with a nice, clean interface and some encapsulation around that. And because I mostly build Java systems, my components, if you zoom into them, well, they're just made up of classes. And that's it. It's a simple hierarchical model to describe the static structure of a software system. This works for Java. If you're using a functional language, then maybe it's not components and classes, maybe it's modules and functions. If you're using a database technology, it's not classes, maybe it's functions and stored procedures. So you might have to modify the things in the structure to map onto your technology. Why am I doing this? Well, what I'm trying to do is I'm trying to create a set of abstractions that I can use to model the static structure of a system. And for me, this is a static model-first approach. And you might say, well, that's fine, but I want to represent other things. I want to understand how a user story is implemented or a use case is realized. And that's fine. If you want to draw things like sequence and collaboration diagrams to show these aspects, well, the boxes on the sequence and collaboration diagrams need to come from your static model. So for example, here's a feature, here's a user story. The sequence diagram is simply the collaboration between components in your static model. If you want to show the deployment mapping, well, the deployment is very simply how you map your containers onto hardware. So in terms of visualizing stuff, in terms of pictures, well, I call this my C4 model. And basically, I will start by drawing a system context diagram. And this basically shows your system in the middle with stuff around it. And I'll show you some examples in a second. I'll then pinch to zoom in to get to my container diagram. This shows my mobile app sending JSON to my web app, storing stuff in the database. I then might zoom into my web app and show my components. And then if I really want some low-level detail, I'll optionally draw some class diagrams. I'm just going to repeat that again. Optionally, I don't normally do the class level stuff because we can get that easily from the code. And of course, I'm not saying you should only draw these types of diagrams, because there are a number of other ways you might want to describe something about your software system. Wireframes, UI mockups, domain models, deployment diagrams. There are a whole bunch of other things you might want to use to describe your system. I think we as software developers are actually the most important stakeholders for software architecture. I don't think software architecture is one of these things that only ivory tower architects do. I think it's for all of us. And that's why I've focused this static model on essentially modeling the system from the system level right down to the code, with a couple of levels in between. So let me give some quick examples. When I moved back to Jersey in 2008, I wanted to find other tech people, and I wanted to keep a list of them, particularly those people who were blogging or tweeting or speaking at conferences. So I built this thing here, techtribes.je. And it's a really super simple, super basic content aggregator for our local tech industry. It basically lists local people, businesses, blog posts, tweets, events, and so on. So this is a context diagram of my Tech Tribes system. The box in the middle with the monkey, that's my system. That's the thing I've built. It has users at the top of this diagram. So these are the various types of users, roles in this case. If you go onto the site right now, you'll be an anonymous user, and you can view all the content. Because my content is aggregated into the site, I can sign in with my Twitter ID and manage my user profile, and there's a super secret admin user. So that's my user community. Roles, actors, real people, personas, however you want to model people. At the bottom are my key system dependencies. So these are the things that Tech Tribes needs to be available for it to run properly. We're pulling profile information and tweets from Twitter. If somebody has registered a GitHub ID, we pull back their list of public repos, and we're subscribing to people's blogs. And that's it. It's just a really simple, high-level picture to show Tech Tribes and how it fits into the bigger context. If we want more detail, well, now we do the pinch to zoom in movement, and we get to level 2. And this is the container diagram for Tech Tribes. It still has people, and it still has my external systems. And basically all I've done is I've exploded that monkey. At the top, there's an Apache Tomcat web application, a Java web application running on Apache Tomcat. It's the single point of access for all of the users. The bottom box is a content updater, and it's the thing that reaches out to Twitter, GitHub, blogs, and pulls the data back. And the data is basically being stored somewhere in that middle trio of boxes. So there's a MySQL database for storing most of the entities. There's a MongoDB store on the other side for storing the tweets and the blog posts. And there's a file system in the middle for the search indexes. This diagram does not tell you anything about clustering, availability, sharding, deployment. That's what we keep for a separate deployment picture. So again, this is just the high-level static structure. It's level 2. If we were interested in how that thing worked, the content of data, we could choose it, pinch to zoom in, and now we get to level 3. And this is a component diagram for the content of data. The content of data talks to the outside world. Those are the boxes on the bottom. And the content of data stores data in those other containers at the top. And again, very simply, in the middle is a Spring scheduled task. It gets kicked every 15 minutes. It uses the various connectors at the bottom of the diagram to talk to the outside world. And there are some other components at the top for pushing stuff in and out of the data stores. And that's it. If we wanted to know more information about the tweets component here, and the tweet component basically allows you to store tweets into a Mongo data store and get them out again, we pinch to zoom in, and we get to level 4. And this is a class diagram of the internals of that tweet component. Public interface, a couple of package-protected implementation classes, and a public exception in this case. So that's a really, really easy set of diagrams. It's a really easy way to describe a software system. Tools. So in order to draw some diagrams to explain how this worked, I've needed to use some tools. And the tools I've used here are basically just OmniGraffle for the Mac. It's essentially a Visio-style application for the Mac. It's a general-purpose diagramming tool. I have to draw boxes, make them the right size, put some text in, make the text bigger, center the text, make sure all the details fit, draw the arrows. It's a very, very manual process. Now, sure, we can build templates to help us do this so we can drag things off a palette onto our diagram. But come on, it's 2015. Why are we doing this? Not even the building industry does this anymore. If you ask a building architect to draw you architectural diagrams, they don't get Visio out. They get a modeling tool out like AutoCAD. So they are much more sophisticated than we are, ironically. The other thing, of course, here is, imagine I'm doing an upfront design process. Well, I'm going to draw some sketches on a whiteboard, and then I'm going to write some code. And what happens about 20 seconds after you start writing your first line of code? Your diagrams get out of date. So why don't we auto-generate the diagrams from the code? Has anybody tried this? Yeah, I can see people sniggering. It's just a horrible, horrible thing to do. There are lots of ways you can do this, of course. You can use plugins for your IDEs. There are static analysis and dependency tools, Structure 101, Lattice, Endepends, Sonar. There are a bunch of them. And there are some UML modeling tools which allow you to reverse engineer. And the problem with those tools is basically they see everything. So you point these tools at your code base, and they just visualize your code base. And they basically give you a mess. And sometimes your code is not even a mess, but it's just because they're showing too much detail. And the problem with most of these tools is that they're showing code. They're basically just reverse engineering code and presenting it in a diagrammatic form. And in Java terms, these diagramming tools are basically seeing packages, classes, interfaces. That's why these diagrams look so complex. Now, of course, you can teach some of these diagramming tools to abstract a bit, but that's hard to do. This is a really great example of what George Fairbanks, in his book, Just Enough Software Architecture, calls the model code gap. So when we draw an architecture diagram, we're drawing modules, and we're drawing components, and we're drawing services, and we're drawing layers, and all these sorts of abstract concepts. But in our code, we don't have these concepts. So Java does not have a component keyword, does it? You can't type public component X in Java and make it create a component for you. There's no layer keyword in Java. We normally create this concept of layers by dumping stuff in a package. You know, we dump all our repositories into one package, all of our services into another, controllers into another. That's the problem here. Our code has one set of things we use, and our architecture diagrams has a completely different set. And the mapping between the two is sometimes impossible to determine. George's book came out in 2010-ish, maybe a little bit before that. This is not a new problem. So far, I've managed to trace this back to the 90s. This is a paper from 1995, I think it was. And basically, it talks about reverse engineering diagrams from code. And even in the first couple of paragraphs, it basically says, as engineers, we like drawing pictures on whiteboards with boxes and arrows. And we can accurately, very accurately, reverse engineer diagrams from code. But the diagrams we reverse engineer never quite match the whiteboard pictures. Again, because the concepts don't meet. So I guess we have to step back a second and say, well, we're drawing components on an architecture diagram. What is a component from a code level perspective? And there are lots of ways we can do this, but let me give you one simple example. So I'm sure you're all aware of Spring. If you don't know Spring, Spring is a framework in the Java world that does everything, if you ask the right people. And part of Spring is a framework called Spring MVC to build MVC-style web apps. And there's a sample application on GitHub called the Spring Pet Clinic. And it's basically a showcase of how to create Spring MVC-style web apps. This diagram down here, the bottom corner, I basically stole it from their slides. And this is an architecture diagram for the Spring Pet Clinic system. So there's a bunch of stuff in the browser at the top. There's a layer of controllers, web app controllers. There's a layer of services, and there's a layer of repositories. When you pull down the code and throw it into your IDE of choice, you get something like the picture on the right. Essentially, there's a bunch of model entity domain classes. They don't do much in terms of business logic. There's a repository package, in this case with a JDBC implementation. There are two others, but I've excluded them for the purpose of this discussion. There's a services package, and that corresponds to the service layer on the diagram. There's a util package because, well, why not? We all have utils, admit it. And there's a web package containing all the web app controllers. So imagine this is your 1 million line code Java system that you've inherited, and somebody asks you to draw a diagram. The easiest way to get a diagram out of this code base is just to generate one from your tooling. If you use a UML class diagram approach, you get that. Don't forget, this is only a tiny code base, yeah? It's like 30 classes, a couple of interfaces, whatever. You could say, Simon, come on, you could have spent more than 30 seconds organizing the diagram to make sure the lines didn't overlap. I tried, it's impossible. It's impossible because basically we're showing everything. We're showing all of the low-level, code-level constructs and all of the relationships and dependencies between them. And this is a small code base, don't forget. Imagine if this was 100,000 Java classes. You've got absolutely zero chance of understanding the diagram. So this is a naive approach, and it's not going to work. So again, let's step back, and let's take a more thoughtful approach. So instead of showing everything, why don't we just restrict what we show on the diagram? Why don't we exclude some stuff that's not relevant to our architecture discussion? So let's ask the question of the code base. Well, code base, what are the architecturally significant elements within you? Now, I'm going to make some assumptions here. I'm going to assume that my model classes, my domain classes, are not architecturally significant. I don't really care about them when I'm having an architecture discussion. I don't think they're structurally important. I'm going to say my repository stuff is, because that was the bottom layer on the architecture diagram the Spring guys used. The service, well, once you see the service, you'll understand it's really structurally significant. I really, really hope my utils are not significant. I'm going to exclude those. And I'm going to say my web stuff is architecturally significant. If we take this approach and regenerate our picture, we get that. That's a bit better. We can now move the boxes around. And you'll see I've tried to recreate the layers that we had before. So we have a bunch of web controllers at the top. We have the service in the middle, and we have the repositories at the bottom. This diagram is still showing code. This diagram is still showing classes and interfaces. And that's why we can now see the true picture of the dependencies between these things. So if you look at the clinic service, well, the clinic service has no dependencies as an interface, but the implementation class does. And you'll see there's some funny tangling in terms of the repositories at the bottom. If this was a Google map, this could be Street View. And I don't want Street View. You know, Street View is great if I want detail, but if I want to figure out how to get from A to B, it's a bit hard, so I need to zoom out a bit. If we zoomed out a tiny bit from this diagram, what I'd really like to get is something that looks more like this. So what I want to do is I want to bundle together the interface and the implementation class, and I'm going to call that a component. So I'm going to make the assumption here that all of my controllers are separate, and therefore they're separate components. I'm going to say my clinic service thing is its own component, and I'm going to treat all of the repository implementations as separate components. Again, this is a sample app. In the real world, you might have a whole bunch of helper classes within your clinic service. You might have a whole bunch of row mappers and things like that within your repository implementations. But again, I want to bundle all of that stuff up. In essence, what I really want to do is draw that diagram. So this is the same diagram with that level of detail just removed. We have the controllers at the top. They use the service uses the various repositories. And I want to draw this automatically. Now, the code is a single point of truth, isn't it? If you talk to many agile extreme people, they'll say, you don't need documentation, it's all in the code. That's not true, but the architecture, the code does embody the architecture. The code is the final realization and implementation of the architecture, of the architectural ideas. But here's an interesting question. Can we get that back out again? So can we extract information about the architecture from the code base? Maybe, maybe not. This is a paper from 1996 by Paul Clements, and he talks about architecture description languages. If you've not heard of the term architecture description language, essentially it's a textual way to describe an architecture, typically the static structural qualities of an architecture. So rather than drawing boxes and lines diagrams in Visio, you use a language to describe the same stuff. Is anybody here using an ADL? No. So ADLs have been around for a number of years now. The most popular one, I'm going to put popular in air quotes, the most popular one that I've come across is called Darwin. I know of 2 people using it around the world. And if you do a search for Darwin architecture description language, you basically end up on a university website. And that sort of tells you all you need to know. That you can download the PDF of the language grammar. It's horrible. Why should I learn this really complex language syntax just to describe my software system? And yeah, I hardly see anybody using these things around the world. But I like the concept. The concept of an ADL is great because then we have something that's textual. We have tooling to support text. We can version control it, diff it, and so on. But anyway, back to this paper. Paul Clements says that in practice, architecture is embodied and therefore recoverable from code. This is in 1996, and he's making a claim that we can get architectural information out of a code base. I don't think this is true anymore. We've come a long way in the past 20 years. Look at the amount of frameworks that we're using that are kind of hiding knowledge. Look at the amount of convention over configuration. I don't think we can extract as much architectural information from the code as we could perhaps in 96. So let's try this. Given your code bases you're working on today, if I asked you to draw me a context type diagram to show how your system fits into the bigger, wider world, could you do it from just scraping your code base for information? So let's take this piece by piece. Can you get a list of people or users or roles from your code base? Now maybe, if you're building something with a user interface and there are security roles in there, maybe you have a configuration file that maps role type to URL mapping, for example. So we could scrape that information out and imply a list of users. Maybe you have a nice enumeration somewhere in your code base that says, here are my different types of users. The role names, for example. Maybe that's in a database table, but I think this is pretty hard to get, actually. You certainly have to write a bunch of custom code. What about the software systems that your system interacts with? Can you get that just by scraping a code base? The answer is maybe. Maybe what we do is we scan the class path of your systems, and we write a bunch of rules. And the rules go something like this. If we see Twitter for J on the class path, make the assumption that this system is talking to Twitter. And that's fine, but we lose all the intent. Why is it talking to Twitter? What information are we getting out of the system? We could scrape configuration files for known API endpoints, and again, make some assumptions, but the intent tends to get lost. What about those other situations where we're just dropping a document on the message bus and it's disappearing? Well, that's definitely hard to kind of capture. And what about those really nasty situations that we say we're never going to do, where our system generates a file, it drops it on a network share, and another system picks it up? And although this sounds horribly archaic, there are still lots of places doing this. So these top levels of information, kind of hard to get. If we pinch to zoom in, containers. Could we draw a container diagram just by scraping the code base? This is slightly easier because we could take your Eclipse workspace or your IntelliJ project file, or if there are any .NET developers here, your Visual Studio solution file, and we could parse the metadata. And we could look for web applications. We could look for Spring Boot apps. We could look for Drop Wizard. We could look for the text public static void main. We could look for database connection strings. So again, we could extract a list of containers from our code base, but it's going to be a very, very hard manual process. Pinch to zoom in. Can we get a list of components for a given application by scraping the code base? And the answer is actually yes. But there's a caveat. And the caveat is, do you accurately have a way of extracting and therefore identifying what those components are? So what rules could you create on top of your code base to describe how you build components? And this is where George Fairbanks talks about an architecturally evident coding style. So this is one of the examples he uses to bridge that model code gap. He says what we should do is we should adopt an architecturally evident coding style. And basically this is simply dropping hints and metadata into your code base so that things in your code reflect things on your diagram. We're trying to make a simpler mapping between the code and the stuff on the diagrams. And there are lots and lots of concrete techniques we can use to adopt an architecturally evident coding style. And here are some of them. So naming conventions is a really, really simple one. So if we have a logging component on our architecture diagram, let's make sure that something somewhere in the code is called logging component. Again, so we can match the two things up. Maybe it's about packaging or namespacing. So maybe we bundle all of the stuff related to a component in its own package. Maybe we throw annotations on things to signify that they are somehow structurally significant. At module, at component, at service, for example. If you're using Maven modules or OSGI modules, or hopefully in the future Java 9 Jigsaw style modules, that's a great example of an architecturally evident coding style, because you'll probably have a bunch of modules on your architecture diagram, and you can find those modules in your code base. JavaScript is just a pain. There are lots of module patterns in JavaScript, require.js and whatever. ECMAScript 6 is also getting support for basic modularity. So again, hopefully that will help clean up JavaScript. And of course, microservices. Microservices is a really, really good example of an architecturally evident coding style. If anybody here is doing microservices and you have an architecture diagram describing your microservices architecture, I'm pretty sure your diagram has one box per microservice on it. And then there's a really nice mapping between a box on a diagram to something in the code. We can probably find those microservices really easily. I'm going to go back to my tweets component for my tech tribes example. So I showed you the little class diagram on the right-hand side. It's a public interface, a couple of implementation classes that are package protected, and an interface. And this is how I've organized my code base. So all of that stuff is in its own package. And I've added my own at component annotation to signify that this is somehow architecturally important. It's a nice clean mapping. That's why when I have my tweets component on my component diagram, if I zoom in, there's one package in this case that has everything inside it. If you look carefully, you'll notice that there's a tweets component impl and a MongoDB tweets DAO. Previously, this was actually a layered architecture. And I refactored my layered architecture to make it more architecturally evident. There's a whole interesting discussion around layered architectures and why potentially layered architectures are bad. And that's too much for this talk. So if you want more information on that, I did a talk recently called Modular Monoliths. And that talks about how we typically organize Java code into layers and why that might not be a good idea. So now we have a way to identify components. What was my initial goal in all of this, like half an hour ago? Well, it was to draw pictures. And ideally, I want to draw pictures automatically. So my strategy is therefore very simply this. Let's get as much information as I possibly can from the code base by extracting it and simply supplement the stuff that's hard to find. I think this is a good approach, certainly for now, until we start embedding more architecture information into our code bases. And I really like the architecture description language thing. I really like the concept of using text to somehow describe my system. But I'm not going to force the architecture description language stuff on you guys here, because you'll all leave. So let's take all of these concepts together, throw them in a pot, and let's create an architecture description language using Java code. Because we all know Java, and we like Java. So here's some code for you. This code is enough code to describe the architecture of the Spring Pet Clinic system. So what is the Spring Pet Clinic system? Well, basically, imagine you work for a vet, an animal hospital, and you are an employee of the clinic. Basically, you use the system to do stuff. That's it. So we have some Java code, write a nice little program. And we're going to create a model of our Spring Pet Clinic system. And then what I'm going to do is I'm going to create a software system and a person, because that's basically all my system is. It's a user using the system. So we can do that in Java code. We create a bunch of nice little domain objects, a software system and a person. And we say that the person, the clinic employee, uses the system. So that's essentially enough Java code to represent the context of our system, isn't it? If we pinch to zoom in, well, what's the container model all about? Well, essentially, it's just a Java web app talking to a relational database. Right, so let's describe that again in code. So I'm going to create a couple of containers, one for my web app, one for my database. I'm going to give them some properties. And I'm going to say that the clinic employee uses the web app, and that the web app uses the database. So again, all I'm doing is I'm very, very simply defining manually the static structure of this particular system. So now I have the context level and the container level. If I pinch to zoom in, I don't want to have to take this same approach to manually specify all of the components in the code base, especially if it's a really large code base. So, this is code, so we can just scrape stuff out the code base. And that's exactly what I do. So I've got this component finder thing, and you plug in different strategies. And in this example, because it's a Spring app, I can throw in the Spring component finder strategy. Now, how do we identify components in Spring? Well, conveniently, we annotate classes if they're important. We annotate controllers with @controller. We annotate services with @service, and we annotate repositories with, you guessed it, @repository. So let's just use that existing knowledge, find the annotated things, extract them from the code base, and call them components. And that's all my Spring component finder strategy does. It goes and finds all the annotated classes using static analysis and reflection. This runs against the compiled version of the app. And there's some logic in there that bundles together the interface and the implementation class. I want to get as much useful information as I possibly can from this code base. And that includes commentary and documentation. And sometimes that's in the Java doc. So I'm also going to use this Java doc component finder strategy to pull out the class level or interface level commentary and add that to supplement my component model. So that gets me a list of components from a code base and their dependencies. We could then use some more Java code, because this is just Java code, to do some additional wiring. So we can say, go and find me all of the Spring MVC controllers and make the clinic employee, the user, use them. And go and find me all of the Spring repositories and make them use the database. So we're just kind of wiring up the top and bottom of our picture. That creates us an in-memory model of our architecture. We can then visualize it in a bunch of different ways. So in this example, I'm going to create a context view, and the context view is simply the people and the systems. I'm going to create a container view, which is my people, my systems, and my containers. And I'm going to create a component view for the web application. All of that stuff is called Structurizer for Java. It's all open source. It's all on GitHub. And there are a bunch of different strategies that you can use to find your own components, naming conventions, that sort of thing. I will build a Java EE version eventually. And the reason this is open source is because I don't know how you've structured your code. So I want people to plug in component finders that reflect their organization of their code. Once you have this model of your code, you can do some interesting stuff with it really, really easily. So this is a really simple JavaScript D3 visualization of that hierarchical model. So it shows the Spring Pet Clinic, the employee, the two containers, and then how the web app is broken up into a bunch of components. Again, that's like 20 lines of JavaScript and D3 code. Also included in the Structurizer for Java open source library is a dot writer. So if anybody here is a Graph Viz fan, this is all done for you. So all you do is you point the dot writer at your model. It generates you a bunch of graphs, and you can then paste them into GraphViz. And you can get a really, really simple basic architecture model out for your Spring web application using GraphViz. It's a bit messy, a bit ugly, but it works really well. Michael Hunger from Neo4j took my architecture model and threw it into Neo4j. It's a graph. And he has a bunch of graphed gists you can go look at. And he's written some Cypher queries. So again, you can start querying the model, looking for relationships, looking for things that shouldn't be related. There's another tool, JQ Assistant, which does a similar sort of thing with Java code, for example. But I want some pretty diagrams. So, vendor alert. It turns out, as of 4 weeks ago, I'm now officially a product vendor, and I do apologize for this in advance. But all of the stuff I'm about to show you is all available for free. So I've built a tool called Structurizer, and it's a web-based diagramming tool. It's a software as a service. You can think of it as software architecture diagrams as a service, which has an unfortunate acronym of SADAS. And that sort of describes me, because every time I go to conferences, I talk about diagrams. And basically what this tool does, it's exactly what I showed you. So you write a Java program or a number of Java programs to describe and extract architectural information from your code base, and then you throw it up via an API using JSON. And these are the diagrams it generates. The caveat, again, it doesn't do automatic layout. So you have to drag boxes around. That's all you need to do. So this is the context diagram for the Spring Pet Clinic system. It's the employee using the system. This is all from the code you saw. This is the container diagram. It's the employee using the web app using the database. And that's the diagram I showed you before. So this is the component diagram for the Spring Pet Clinic web application. All automatically generated. You just drag the boxes around. The commentary, the text in the boxes, that's the java.client. I've added some styling. I've added some shapes. You might say, well, what do the shapes mean? Well, yeah, because it's all in the model, we can automatically generate keys out of it. So this makes it really, really simple to create some nice diagrams and make them understandable. The other thing we can do is we can go back to our maps concept. And we can start linking our components to our source code. Again, because it's just Java code. And what that means is if you go to the diagrams on the web, you can double-click a component, and it basically takes you to the source code on GitHub. And that's kind of what I wanted to do. I wanted to create a set of maps for a software system at a high level right down to the code. So you get your million lines of Java code, somebody gives you a set of maps, and you can navigate the maps, and you can jump straight into the thing you need to change. So again, it's that hierarchical model. It's context down to containers, down to components, down to essentially the code. You can also do things like create dynamic diagrams. So if you want to show how a particular feature or user story or use case is implemented, then we can create some dynamic style diagrams. And this is basically just choosing a path through the application. In this example, I'm basically hard coding the route through the application for the view list of pets feature. But of course, if you were to run your Java system and output some stack trace information, you could assemble this or reassemble this dynamically. And since this is all web-based, we can just animate it. So, we can have nice, simple animated diagrams. Now, this is a small app. The Spring Pet Clinic system is not very big at all. It's like 30 classes, 10 components. Does this approach scale? Does that look as bad as it does down here? Yup. Now, I can explain this diagram to you, but I shouldn't have to. It's too complex. It's showing way too much stuff. This is the component diagram for my Tech Tribes web app. All of the web app, the Spring MVC web app controllers are on the top, and all of the boxes in the middle are my components. But again, it's showing all of them. We're falling into exactly the same trap here as the other diagramming tools. I don't think this code base is a mess, but the diagram is. And you might say, well, you could just get a larger piece of paper. No, that doesn't solve the problem. It doesn't reduce the amount of complexity on the diagram. But of course, this isn't a static diagram, is it? This is not a Visio diagram. It's a visualization of a model. And because it's a visualization of a model, it's really, really easy to write some more code to slice up the model. So in this case, we can say, right, rather than showing all of the components in my web app, why don't we find all of the Spring web app controllers and create one component diagram per controller sliced through the system? So we're sticking with the same levels of abstraction, but we're just slicing the diagram up. And essentially what you get is a larger number of much, much simpler pictures. And I think this is the better way to approach scalability of complex systems, particularly when you're kind of documenting them. And of course, you don't have to do it by controller. You could do it by functional area or aggregate root or bounded context or feature set, entirely up to you. That's the beauty of having all of this information in code. Throw that sort of concept into your build pipeline, regardless of whether you use my tooling or not, and you get an architecture model that's continuously kept up to date. You don't get that horrible situation where the stuff on the whiteboards never reflects the code. You have these big A3 or A0 plotted printouts. The last updated date says 2008 because it's just too hard to change. Somebody new joins your team, you point them at the maps, they're up to date, they can find what they're looking for easily. So again, I'm trying to increase the amount of architecture documentation we're producing, but actually make it useful and relevant to us as developers. And that's really the entire point of this talk. The entire point of this talk is if the software architecture model is in the code, ideally by using things like architecture-level encoding styles and creating a much more modular code base, you can get it out of the code. Thank you very much. So the clock is saying we have 7.5 minutes left. That seems wrong. 5 minutes left for questions. Any questions? There's one here in the middle.
Yeah, you're going the exact opposite direction of model-driven development. You're creating diagrams for your code instead of generating code from your diagram. What do you think of MDD?
So the question is, this approach goes exactly the opposite way for model-driven development, where we create a model of our system, we tag in some code to make it executable, and we forward-generate code. And the question was, what's my view of model-driven development? It's not something I particularly like, is the honest answer. We tried it 10, 12, 15 years ago. It has a couple of interesting applications. It might be useful for product companies, but as a technique for building software, no, I don't think it works. Not yet, anyway. There's one down here in the front.
Are you also able to generate sequence diagrams?
So the question is, am I also able to generate sequence diagrams? So with my structurized tooling as a product vendor, no. I don't think sequence diagrams show you enough information given the size of the diagrams. So this is why I prefer the collaboration style approach. But again, you could very, very simply write your own tooling to extract things from your model and throw it up to something like websequencediagrams.com. So again, once you have that model, you can do a bunch of interesting stuff with it.
It's easily extensible?
It's easily extensible. I mean, all of that core library that does all the hard stuff is all open source, so you can plug new outputs and exporters into it. Question over here?
To extend the previous question, so what about the complex integrations with external systems, where the sequence diagrams would be very helpful?
So what about...
Twitter, right? But it's quite simple.
Yeah.
What about the more complex?
So the question was, what about more complex interactions between your system and other systems like Twitter? You've got a couple of options here, I guess. One is to put some information into the code so that when that code is executed, you log out stuff that you can then parse and create a model from. The other way is to do it manually. So if you have a small number of integrations, you might find it's quicker just to create a view of that scenario manually using code. If you have lots of them, say in a microservices or messaging style environment, then you might want to dump some stuff into your logs and then post-process that and create some diagrams and models out of it later. There's no real easy way to do that. A couple of questions here. So first one.
How strong is your dependency on Spring? You said you want to provide a Java 18 version. How difficult and how far is that?
So the question is, how strong is the dependency on Spring? So there is a structurized Spring module in the open source project. And if you need that, then you pull in Spring. Otherwise, you don't need Spring at all. So it's independent of Spring. The core library is independent of Spring. And behind?
Yes, I think something similar has been suggested and provided by Together J 15 years ago and has failed miserably to what I said, and I found it very promising, but unfortunately it's gone. And have you seen why it failed and how you can avoid that your approach fails the same way?
So the question is, Together J from 15 years ago tried something similar. So I was a big fan of Together J. If you don't know Together J, basically it was a tool, and you would point it at your code, and it would draw diagrams for you. And the two things would remain completely in sync all the time. So you could modify your system by adding code, and new boxes and things would appear in a diagram, or you could drag a class as a box onto a diagram and wire it up, and magically code would be generated. So it was a complete round-trip engineering tool for building systems. It tended to be quite slow on systems of any scale. And again, it comes back to that same thing. It was showing you classes. It was fundamentally showing you a visualization of the code. And I think that's too complex. So my approach is, as I said, is to kind of step one level up so that we are reducing the amount of complexity that we're showing on these diagrams. So that's why I'm really excited in this as a slightly different approach. This is also why I'm really excited about the Java 9 modularity stuff, because I think the Java 9 modularity stuff will fix a bunch of problems that we have now. Let's go down here.
Should we consider using RDF for the model, for the memory model, for the model of the architecture, and then use inference on the taxonomies and mapping between objects? Like, one interesting thing would be to see how a bunch of things in one architecture can be refactored into another architectural paradigm using inference.
Right. So the question is, have I looked at using RDF as a way to represent the architecture model, and then we can use inference and throw the kind of taxonomy stuff on top? The short answer is no. But again, it's all open source, so because you have an in-memory model, you can dump it out as any format you want to. Interesting idea. Over here.
What do you suggest of Microsoft Visio? Because you must write the picture not before code.
Yeah. So the question is, Microsoft Visio is never going to die, right? Because we still need to do architecture before we write any code. And that's really, it's a two-pronged approach for me. So if I'm doing an initial upfront design exercise, yeah, sure, I'm going to draw pictures on whiteboards and pieces of paper, and I might use tooling like Visio. Once we have the code, that's when I want to start auto-generating the diagrams. Of course, people need to do presentations as well before they write code, especially if you're a consulting company doing proposals. So there's always a little need for Visio, but I'm trying to get people away from Visio as much as possible. We have 1 minute, one more. There.
Actually, the way I see it is a kind of code comments on steroids, in the sense code comments that can be executed as code.
Right.
Don't you think that there is also the risk that after a while the description of the architecture that you made in code will be obsolete, like from comments in code?
So the comment was, this seems like code comments on steroids. Is there not a danger that the code comments in the code will diverge from the real architecture? And I guess the answer is, if you're using lots of annotations and you're putting this metadata to supplement your code base, then that's definitely a risk. If, on the other hand, we find a much better way to extract automatically useful information, so let's say we all adopt Java 9 modules, and we write a component finder that says, right, I'm going to find all Java 9 modules and their dependencies, and that's a much stronger model. It's a much richer, much more accurate model with less risk of floating out of date. But you're definitely right, there are inherent risks in all this. Superb. Thank you very much.